Good evening, everyone. So I'm just quickly walk you through some of the optimization tips we can do for the PG vector performance improvement. We know like RAG is one of the cheapest mode to provide the context to the models to behave them as we want. And as we are talking about the dimensions, PG vector, we are talking about dimension, which generally is more than 1500, and it is a huge set. And with this huge set, we need a lot of memories. If we are putting all of them in memory, we might need a lot of big instances, and it might face a lot of eviction. So some of the challenges which you are seeing on the screen. This is a very well-known slide. We know like PG vector is an extension which provide various capability, vector data type, indexing methods, and all. So what I wanted to discuss, like one of the solution which is very common for the performance improvement is like a proper hardware selection where you can get a good instance type or some NVMe storage which will support TBs of in-memory storage for your vectors. But some of the improvement which we can do as a database expert while creating these PG vector, for example, considering few of the index build parameter, how you are building those indexes, while searching through those vector, how you can tune some of the parameters, how you can use filtering to improve the performance. So for example, IVF flat, one of the index strategies where we create the cluster of the vectors into group of the vectors into a cluster. You have a parameter which you can tune, which is called list. So generally, if you have 10,000 of vectors, you can take a square root and you can start your building index with a optimal number, and then you can improve the number as per the accuracy you want. Similarly, while this is at the build time. Now, when you are searching through that, you can use the props, which is another parameter. And same like more you increase the prop, your performance will increase, but definitely the build time will be slower. For HNSV index also, like when you're creating an HNSV index, which is a graph index, you can consider some of the parameter. For example, M, which is the connection per layer. So how many connection your graph need to be have to the next layer. And then EF construction is like a traverse list when you are building an index, how many of the next neighbors load that need to be traversed. So both of these parameters improve the accuracy, but definitely take more time. So start with the default, do a run, then see if it is fitting in your accuracy level, and then stop. Similarly, at the search point, you can use EF search. This is a customizable parameter which you can use at the time of querying the HNSV index. Some of the things which we can do at the query level, like for example, we already have limit, right? So similarly, when you're writing a query to search from the indexes, you can use the limit, which will definitely improve your performance, force the index and scan. Then you can put distance threshold. You know the distance between two vectors is, you want that to be less than 0.3. So at the time of querying itself, you can put like, okay, select the data which is having the distance of these vector between 0.3 like that. Or you can combine with the traditional filter, you can do a hybrid search. So before you are going for to look for a fridge, instead of a big dimension, you can simply first categorize as a electronics and then go to the check for the embedding of a fridge. Okay. Some of the thing which we can do is at the distance, various distance operator which is provide. For example, Euclidean distance, which is a distance between two vectors. So if you are building a geometric application where you have distance matters more, you can use Euclidean. If you are building an application which is not exactly in required distance but a direction. For example, you want a movie which is a recommendation of a movie. You can use cosine. So these are some of the things which we can do while building and searching the index at the database level to improve the performance. Thank you.